Okie dokie. Sorry, we're a little bit late, but the last session was a little bit late. So, look at that title right there. I think that title's kind of bizarre. It's been something that I've been thinking out personally, thinking about, for a very long period of time. And it's the whole security kind of reliability debate. And so we have a great set of panelists right here. I will introduce them one by one as they come up, give you their bios very briefly. But that's kind of the topic. I mean, security, that's always a community. Certainly the reliability folks, that's a community. So, the kind of question is there some intersection? And because the name of this conference is SERE, which is security and reliability, maybe there's something we can discuss and talk about that actually discusses the trade-offs between those two. So these are kind of the questions that I've asked the panelists. I'm going to give each panelist 10 minutes to make a statement. A couple of the panelists have slides. The rest did not bring slides, and they just want to talk at the microphone. But, is that a well-formed question? Does reliability trump security or vice versa? Or is the entire question that I formed, and I've thought about this question for a long period of time, is a complete nonsense? Or is there some function within this question right here that deals with context and environment? Because most things, I know, certainly Connie would say in the safety critical community, it's a lot about environment and it's a lot about context. So is there any of that that applies here? My fourth question right there that I really love is unreliable security still security? So if your security mechanisms are completely unreliable, but you put them in there, you built security in, but it's completely unreliable, can you still claim you have security? And I think that's an interesting question. And the very last one right there just came out in CACM a couple of weeks ago. And I'll just let you read it. I don't need to read it to you. But there obviously is, according to Dan Greer, there was an interesting relationship between reliability and security. And so I was very enthusiastic when that came in my mailbox, like I said a few weeks ago. And so that's pretty much how I wanted to start this panel off. So having said that, I would like to introduce Jeff Payne. He is the CEO of a company called Coveros in Virginia. He's a former business partner of mine. He was the CEO when I was at Cigital and RST. And I'd like to invite him up and give his thoughts to this question. So thanks, Jeff.
Thank you. Yep. So I'm the guinea pig. I get to go first. Yeah, thanks, Jeff. I appreciate that.
That's why I did it.
So who trumps who? Reliability and security. I have a couple thoughts. And I'm going to take my thoughts and my direction from being a business guy. And for the last 20 some odd years, I've been dealing with customers out there, helping them with reliability and security. I've learned a lot about what they want, what they don't want, what they like, what they don't like, that I'm going to try to weave into this conversation. First of all, I don't think it's a very well-formed question, but I think it's a great panel topic, right? Because there'll be a lot of different opinions and thoughts, which is what makes a panel interesting. When I first saw the title for this panel, the first thing that struck me was the word trumps. Right? I play cards. I like playing cards. And the word trump means a certain thing in some card games. But the word trump means a lot of different things to a lot of different people. So I started thinking about, what does trumps really mean? And if we look at the different ways you might think about that word and its definition, what does that mean for reliability and security, and which one's more important? And how would that help me answer this kind of interesting, non-well-formed question that Jeff has posed to us all here today? So let's talk about the word trump. So the first definition I come up with when I think of trump is related to what a trump card means in cards. And that is something that's very important, right? It's a card in some games that's more important, or a suit that's more important than others. So the first way I look at this question is really rephrasing it as, what's more important, security or reliability? Well, I guess in my view, the answer to that has always been really simple. It really hugely depends on the application, right? For some applications, reliability is everything, particularly security applications. You know, quite honestly, if someone dies because software fails, I don't really feel like I can get up in a court and tell a judge that I didn't spend money on safety and reliability because I was worried somebody might hack in and get access to some stuff they potentially couldn't get access to. So I always look at, what's the consequence of failure? What's going to happen if this thing fails? And how big are those consequences? And for some applications, reliability is hugely more important than security. For other applications, it's exactly the opposite. For instance, national security, security secrets, other things that drive our national security on an international level, we need to protect. The security of that information is hugely important. We had a breach of that information recently that could have huge implications to the United States. One other note, so when I look at that question, to me the answer is clear. It depends. It depends on what your application is. It depends on the consequence of failure. It really depends on the risk. So from that aspect, I think it really depends on the app. Second way you might look at the word trumps is, which one subsumes the other? Is one bigger than the other? Is one part of the other? And this is where the debate obviously gets interesting, because people have been debating this about reliability and security and quality and all this stuff forever, right, in our industry. So here's the way I look at it. First of all, let's talk about the definitions, because to me it all gets down to how you define these terms. All right, the classic definition of reliability is what? Probability of failure-free operation at a given time in a given environment, right? We've all had that schooled into our head. I think that's the IEEE definition of reliability. And that is, you know, the formal definition of reliability. Pretty narrow, if you think about it. Because, you know, being someone that's been involved in security, I can tell you that security people, they don't operate within a given time, within a given set of constraints, within a given intended use. In fact, they try to look for ways that the software, they can get around those things, to do things that they want to do, you don't want them to do. I don't know how many of you have done software testing, but if you have, you've probably experienced the situation where you found a bug, you've gone to the developer, showed them that bug, and the developer says, why'd you do that? You're not supposed to do that. Why'd you do that? The software's not supposed to do that. Well, that's what hackers make a living of, is trying to figure out what they're not supposed to do and figure out how to leverage that to their gain. So if you look at reliability from that very narrow definition, and maybe formally a good definition, I would argue that security subsumes reliability, because also if our software has low reliability, one aspect of security is availability and denial of service, and you can argue that low reliability may result in security issues like denial of service. On the other hand, let's talk about Microsoft's Trustworthy Computing Initiative. When Bill Gates rolled that out 11 years ago, he said, we're going to make our software reliable and secure. Now, if you read what he says thereafter, he's not talking about the IEEE definition of reliability. He's talking about making the software high quality, good enough and acceptable for use by the customer. All right? And if you use that definition for reliability, then security is subsumed within reliability. Because I believe, personally, that software security is way more about software and quality than it is about security. We need to figure out how to build it so that it works. We need to figure out how to specify it properly and make sure that unintended consequences aren't possible. So again, depending upon how we define reliability and security, that determines whether one trumps the other. So I would say, again, my conclusion is it really depends. Last but not least, we can't forget about the customer. All right? Deal with a lot of customers, and I'll tell you that customers aren't always logical. I'm a logical guy. I have logical degrees. I like to think logically. There's a lot of irrational people out there. And, unfortunately, we run into them every day. So what a customer wants might not be what's most important or most useful to them or whatever. They want it because they want it. Good example, a non-software example. A lot of customers want various certifications. We do a lot of agile development. They want Scrum Master certification for people that come in as Scrum Masters. I can tell you that the Scrum Master certification is worth nothing. There's nothing you're going to teach a project manager in a day or two that's magically going to make them good. All right? It takes years of schooling. But yet people want that because they believe that inherently is important or worth something. And so the third question is, what does a customer want? Do they want security or do they want reliability? And the answer is they want whatever they think they need. And that might be based on regulation, policies, standards, what their boss told them is important, an illogical thought about what's important. And so once again, I would say that when you deal with customers, the answer of whether reliability or security trumps each other is it really depends on the people that you're dealing with and what they care about and where that caring comes from. So I guess to wrap up, I think I'm probably out of time. Yep. In summary, every way I look at this question, I come up with the same answer, which is it really depends on your definition for these words. And I'm okay with that personally because I think we are in a business that is very context sensitive and context driven, and we can't be lazy and just blanketly say one is better than the other in all situations. So with that, I'll turn it back over to Jeff.
Thanks, Jeff. So our first panelist basically said, what happened to my slides here? What did I do? First panelist says, on the fence. So that's fine. We'll live with that, Jeff. We will move on then. Okay, so Brett, are you ready? So, okay. So I was hoping to get like half one way, but if they all sit on the fence, then what am I going to do, right? There's nothing I can do about it. So you take over.
Okay. Good morning. I'm Brett Michael from the Naval Postgraduate School, and I'm actually local. We have a campus here in Northern Virginia. So I would take a very, probably not necessarily controversial view, but a different view. I look at reliability and security as orthogonal. Okay, so it's not a decision of one or the other. You really need both. And that's where, in the development of systems, I do a lot of work in the U.S. federal government sphere, and everything I say today is my own opinion and should not be attributed to the U.S. government. It's my disclaimer. But we look at how we can get as much reliability and as much security and as much safety and fault tolerance as we can into those systems, applications, and in today's world, we deal with services like cloud services. So I do see that there's not really a trumping here. It's trade-offs, but I see reliability being very different from safety, security, and other abilities. For example, safety and security are very similar. They have similar goals. You look for security hazards, security and safety hazards, and the faults, failures, and that contribute to the hazards that lead to the incidents and mishaps, okay, whether they're security mishaps or safety related mishaps. But reliability is, I think, fundamentally different. It's about how do we best use the resources we have to perform the assessment. So how do we best construct systems so that they're testable? And we have finite amounts of resources to do that with. And we have to balance reliability with, the system engineering. I hate to talk about system engineering, but the system engineering aspects of, cost and schedule. So there are all these other trade-offs, but really reliability is about focusing on the resources and how to best focus those resources to perform the assurance task. And this idea of one ility trumping another, I always like to refer back to an example Professor Nancy Levison of MIT gave me when I was a graduate student, not under her, but I had the pleasure of sitting down with her for an hour and talking about just this type of topic. And she related that story that some of you probably have heard from her at conferences about the paranoid torpedo. It was a torpedo developed by, I think it was Hughes Electronics back in the 80s, where Hughes tried to put as much safety into that system. So they were trying to protect from anything that could possibly go wrong. What happened when they tested that torpedo repeatedly? Well, the torpedo it would launch and then it would sink to the ocean floor. How many people have heard this story? Raise your hand. No? Nobody? Okay. Well, she actually told this here at NIST about 20 years ago at a Compass conference, IEEE Compass conference. And what she was trying to demonstrate with this story is that you can put too much emphasis on one ility, like security, and in this case, you lose out on mission effectiveness. And in that case, the system was quite reliable. It did there was assurance and trust that those safety policies, just as we have security policies, were enforced. However, the system was not usable, right? Because the torpedo would never reach its target. And the problem here was this was a torpedo that would hone in electronically on the enemy ship. The concern here was that the torpedo didn't come back and hit the ship that launched it, right? So anyway, I hope that relating this story now, another generation or several generations will remember this story, and it's not about either or, but it's really about how we can optimize across the different ilities. Let's see, other things I wanted to mention. In many of the systems we have today, there is such an emphasis on security, but people, I think there's a sort of a barrier or a gap or something. There's like a divide. You have people that are very security conscious and other people that are really focused on topics such as reliability, and we need to get those people to talk more amongst themselves to see how they can do a better job of making those trade-offs. And also, for example, from a reliability standpoint, making a system more testable, and from a security standpoint, making it so that the reliability people understand what those requirements are that they're trying to assure to. So with that, I'll let the next speaker.
Are you back on the fence with Jeff?
I'm not on the fence. I'm actually saying that these are two orthogonal. That's the fence?
That's the fence.
Okay. Yeah, I'm on the fence then. Okay.
Okay. Well, so Phil, you're up. Let's see. Let's see. You've got slides
so
here.
Jeff, brings up, I've got a handful
Well,
of
while I
slides.
try to, I'm not sure where they're at.
I
But,
can probably go without them if necessary.
yeah, they should be in here somewhere. What's your name?
The second one, yeah, there it is.
There you go. Okie dokie. There we go. So anyway, something I forgot to mention about Brett, and then I'll talk about Phil. Then we'll start. So Brett does a lot of work in this area of what are the international rules on cyber warfare, right? Is that a correct statement? He's done stuff, for NATO and other, I can say that, right? I'm allowed to say that, okay. So otherwise, something would have to happen today that wouldn't be pleasant. But yeah, so Brett does a lot of work. He's been out in Monterey. Now he's in the brand new campus of the Naval Postgraduate School in Arlington, Virginia. So I'm sorry, Brett. I forgot to mention that. And he writes great articles. He's got a brand new column out right now in Computer, right? In Computer Magazine, the security column. So let me tell you about this guy over here. So this guy over here, he's another interesting friend of mine. He's a full professor at Penn State University, And you're at the Great Valley campus, not the main Penn State University. And I think you only teach graduate students, right, Phil? So it's all graduate students. He's written 20-plus books, if you can believe that. I can't believe people can write 20-plus books. I got out 2, and I just gave up on it. That was my limit. But anyway, Phil, he's really interested in this area, and we've been talking for a long period of time. He's on the board of governors of the IEEE Computer Society. He's had various positions, vice president of publications right now for the IEEE Reliability Society. So he's got a lot of quals when it comes to professional societies and things like that. But I'm going to be really interested to hear what he says right here, because he talks about security versus privacy, and the topic of the panel was security versus reliability. So we'll see what happens.
Thank you. When someone has to go that far around the block to do an introduction, you know he's really struggling there for me. But thank you. I appreciate that. I'm probably the least qualified guy here to talk about this. And in fact, you'll see that I've refined my perception of the discussion to focus on the non-IEEE definition of reliability and instead focus on one of the qualities that customers, users would perceive in some ways as part of a reliability space, and that's privacy. It's also timely, of course, given the events that have happened, well, over the past several years, but especially over these past couple of months. And I do apologize, this is an international conference, but I'm confining at least this historical background only to a U.S.-centric perspective. And unfortunately, I'm on the fence. I didn't realize I should have taken a controversial position. Maybe at the end of the day, this is the controversial position. But what I wanted to understand is to what extent have public citizens and corporations accepted intrusions into their privacy for the sake of security. And as it turns out, it's pervasive throughout history. It's not new. Typically in time of war, it's accepted quite eagerly, in fact. We can argue about whether we're at war at any given time in history. But let's just take a look at this real quick. It's something different that I have to offer to this panel. I'm watching the atomic clock there to make sure that I'm keeping within 7 minutes and keep us on schedule too. So don't worry. 10? Oh, even better. I can expand infinitely to fill any amount of time. I'm a professor. That's all we can do. Interestingly enough, during the American Revolutionary War, there were some instances of sacrificing privacy for the sake of security. But interestingly enough, during the Revolutionary War, even amongst the officer corps in the armed services, there was a lot of illiteracy. So there wasn't a lot of concern about, censoring mail or intercepting communications. Of course, there were no electronic communications to monitor. And most of the eavesdropping or sacrificing of privacy was, spilling the beans in the tavern when you got had a little bit too much, buttered rum, and somebody managed to convey that information to one side or the other. So, and certainly in the farmhouse or even in the small cities, there wasn't a lot of concern about monitoring. I couldn't find any evidence, although it probably exists, of actually censoring newspapers. But again, because illiteracy was so pervasive, it wouldn't have been a very big issue at all. During the Civil War, there was increasing levels of security versus privacy trade-off sacrifice. By now, we have the technology of telegraph being used to communicate between the armed forces, also between private parties in some cases, between the news services. The capability to wiretap pretty much was concurrent with the technology of being able to communicate over telegraph wires. There was some monitoring of postal instruments, mail, but typically this was just done from the prisoner of war camps. So outgoing mail from the prisoners would be screened before it was delivered to their destinations. Of course, there was lots of espionage going on, from the north through Canada, at the border, at the Mason-Dixon line, and that was a form of intrusion, right? You would be subject potentially to search. But of course, the most famous I think, instance of sacrificing security and privacy was the infamous suspension of habeas corpus by President Lincoln. Of course, that is the principle by which you could be held by the authorities without being charged with an actual crime. So that's part of the Bill of Rights, that if you're going to be held, you have to be charged with something. You just can't be held for no good reason. But it was suspended during the Civil War typically because of fear of espionage activities, and in some cases it may have just been a delaying action. By the time we get to World War I, now we have much more, we have more literacy amongst the masses, so there's more mail going on between people, more private communications via telegraph. There is some early wireless radio. There weren't actively broadcasting wireless radio stations during the First World War. There were a couple, but nothing to speak of. But there was active censorship, monitoring and censorship of all of these instruments, right? So, there'd be somebody looking over the shoulder of the editor in a newsroom and, making sure that, what did they say? It was a World War II saying? No, it was a World War I saying, loose lips sink ships, I think. Was it World War II? You were there, Paul. Thank you. Just kidding. Yeah, very famous. Loose lips sink ships. So it became increasingly acceptable, I suppose. World War II, of course, very famous instances of violations of privacy. Probably one of the most infamous was the internment in the United States of those of Japanese origin in prisoner of war camps, or, well, they didn't call them prisoner of war camps, excuse me, internment camps, for the purposes of controlling their movements and communications. There was lots of censorship of mail. Now we have active radio stations broadcasting, and, of course, you can see lots of older movies, in fact, from the 40s and 50s had little subplots involving, radio commercials during the, the Ovaltine hour, actually broadcasting some encoded messages to the spies to tell them to Alfred Hitchcock movies were famous for that during the 40s. Saboteur, for example, was one that you can watch if you want to see a fictionalized account of this sort of thing. And there was lots of the other things going on, wiretapping, of course. Now telephones could be wiretapped. And in fact, by the way, I researched that the laws that permitted for wiretapping of telephone communications go back to the 1880s and 1890s. So imagine that, even with one of those little, crank telephones somewhere on the line, the telephone repairman up on the pole might have been actually listening into your conversations. Of course, the Cold War is famous for, now the technology has improved where we can have all kinds of spy bugging devices in, shoes and walls and paintings and gifts. James Bond movies from the 60s, 70s, and 80s notoriously featured all this kind of activity. For example, of course, we had the famous McCarthy investigations, which in many ways people considered intrusive intrusions into their privacy. So that more or less brings us to today, where we, if there's in fact a war on terror, you can believe it or not. What has changed, though, over these years, and the theme I was trying to weave as I wind down on the atomic clock, is that American citizens have always sacrificed privacy for this notion of security. What has changed over time is the technologies, the ability for the government and our enemies to employ these technologies in fantastic and even unfathomable ways. I'm sure I don't know all the different ways that these technologies can be used. And what's more, the amount of information that can be collected is massive. And now today, what is even more, I think, compelling, frightening, challenging, whatever word you want to substitute there, is the fact that we have the ability, with these giant Google data centers or their clones out in Utah, to analyze this information, to aggregate and analyze this information, and to use very powerful data mining techniques, pattern matching, whatever is available, to draw inferences from this information and then take action on those inferences. So what worries me, I think, is that these technologies they're pervasive, they're becoming increasingly so. The ability to utilize this data, we talk about big data, Internet of Things, all those fancy buzzwords, they can all be turned into invasions of privacy at the sake of security. But we're accepting this, and maybe it's a good thing. Maybe it's not. I think I want to remain on the fence, see what the others have to say, and then maybe I can be swayed after today. So that's all I wanted to say. Thank you.
I got a bunch of fence sitters, huh? Yeah, what I got today. Oh, a bunch of fence sitters. Well, what can you do about that? Okie dokie. Let's put that thing down. There we go. So our next speaker is Angelos. You ready? Okay. So let me tell you a little bit about Angelos. I started a project at NIST, which is where I work, some years ago. And I had a colleague that I used to work with. So anyway, he said, do you want to meet this guy named Angelos? This guy named Angelos, he's doing all this great work in, Android, smartphone testing, all these different things. And I thought, well, that'd be kind of cool to actually meet this guy. And so that's how it worked out. So now he and I have been working together now for about 3 years on that DARPA project. He's gone off. He's got his own company. He does his own things. But anything in security and reliability, Angelos is one of my go-to people whenever I need advice on, different technical topics. So hopefully he'll give you a great 10 minutes. And if you get time in the hall later to meet him or any of the other panelists, it'll be well worth your time. So thanks.
Thank you, Jeff. I want you all to wonder why we have this new discussion about reliability and security and who trumps what. It's because of recent failures of security that we notice happening in critical infrastructure. For example, power. We've seen state-crafted attacks, for example, for specific nuclear installations that are outside of this country. The reason that we see this happening is because, unlike all the other fields of engineering, software engineering is the only field that doesn't have metrics to measure reliability and security of the products that we make. So, for instance, nobody was ever held accountable for creating software that led to data loss or to actual loss of a critical infrastructure. However, if you go back in time, there are many, many people, engineers, that are held accountable for lack of designing a bridge, for instance, reliably, right? So, for example, if you cross a bridge and, God forbid, something happens, you go back and find out if it was the load on the bridge that created the problem, if it was the bridge itself that was not well designed, it was time that caused the problem. There is also some sort of investigation which leads to reasoning, right? How many of you are familiar with investigations that involve software? How many people are held accountable for creating bad software? How many people? Zero. There was absolutely zero cases in the United States and throughout the world where people were held accountable for creating bad software. How many people, how many, do we have monetary loss in terms of financial? Of course, right? Many people lose money, data. We sometimes lose lives too. And the reason that this becomes a problem is because recently systems that are badly designed or systems that we never thought that they will work a specific way are coming into light. I will give you very specific examples. All of you are utilizing your power, right? Nowadays, power companies are trying to put smart power meters into the homes. These power meters are connected to the internet. They were never meant to be connected to the internet and be reliably read, but only by the company. But now, since we have this internet, this glue that connects all this bad software to people that can exercise the software from very far, we are actually creating a new model of attack which allows people to go and attack the reliability and the security of these systems. We would never care less if the power meter, when the power meter was just a dumb box that someone was going past reading, even if it had electronics, even if it had software, nobody cared about it. Now it becomes part of the internet, everybody cares about it. I'm going to point out there is an internet project, an internet search engine, that looks into various, I would say, critical infrastructure, web cameras, and all these SCADA type of systems It's a search engine that you can log in remotely and see all of those places. For example, sometimes if you have time, you can go and take a look at what is the traffic in Switzerland at this moment. This is a very powerful thing, and it opens up two problems. Number one, is all software going to be reliable? The answer is no. Is all software secure? The answer is again no. Can we create damage after we have the internet, which is a glue that connects everything? The answer is yes. All these problems that were hidden in the code are now out there for everybody to find out and exercise at its own discretionary power. So when it comes to reliability, I would say something can be reliable, but the context is the most important keyword here. So for instance, is our projector reliable? Maybe yes. Is our projector reliable connected to the internet? Maybe no. Is the projector secure connected to the internet? Maybe again no. Folks of mine, very good friends of mine, have actually found out that if your printer is connected to the internet, people can just read your documents and print out whatever they want by reprogramming your printer. Is it the printer's fault, or is it the fact that we connected it to a medium that anyone has access to access the... I mean, this is an open question, right? So if we take a bridge, a regular bridge that we have between, let's say, DC and Maryland, and we put it inside the swamp, would the bridge operate the same way? The answer is no. But we accept all the fact that an engineered project under specific specifications, we are able to measure it and understand how it works. But for software, we expect it to work no matter what the context. And that's the failure that we have. We don't have metrics to understand when software fails, and we don't have mechanism to measure it ahead of time and predict the failure. Everybody's connecting things into the internet, but they don't have a mechanism to measure if they're creating a new risk or if they actually alleviate it. Most of the and another part of the problem is that our software engineering industry is being rewarded not based on the reliability and security, but based on how many products they're actually cranking out. Nobody's going to be paid for reliability or security of a product. It's an afterthought. If something happens, everybody's looking forward to fix it. But that's not the way it should happen. Finally, I would like you to think how the internet looks like today. Someone, let's say in Europe, can scan a server here in US without any repercussions and without being held accountable at all about an activity that can happen in a completely different administrative jurisdiction. It is the equivalent of someone from Europe being able instantaneous to be on your front door and check if your door is locked or unlocked, get in, steal something and leave. We wouldn't like that example because we want us to have borders and we want us to have mechanisms to control the type of traffic that we receive. Right now, we are not at that point. Actually, we're very far from that point and towards a point where everybody can do everything and not even be held accountable just because he's in a completely different administrative jurisdiction. So when security and reliability comes to mind, I think that the most important question is what is the context? And do we have any metrics to measure it and prevent usage cases where we didn't expect this to happen the way we did? In that case, for this, for example, I agree completely with Jeff Payne. It is a really matter of perception, right? What someone perceives as reliability, someone says it's security. Whatever someone says it's security, it might be really reliability. Availability is not the only part of reliability. Reliability is also the capability to operate under specific assumptions and rules. And currently, we don't have that. What we have is like anarchy. At this point, all of you have computers in front of you and phones, right? Who certified that the software that you have on the phone works? Nobody. Can someone provide you guarantees that the software is going to be working if someone launches an attack or if someone tries to get your personal data? No. If this happens, who is going to be held responsible? No one. So think about, you walked into this room, right? If something happens in this room, someone is going to be held responsible because he designed it, he built it, there are procedures. There are no procedures for software engineering at this point. And until our field matures to the point where we grow up and we put those rules in place, the same problem is going to perpetuate. The only thing that we did is we opened up the doors to have more people being able to bang down the software, because that's exactly what internet does. We took systems that were inappropriately placed on the internet because they were not ready, and now we have these problems. So to recap, I do think that the two are in tandem, and it really depends on the context. So there is no trumping of one over the other. Actually, at the end of the day, the end user wants to be able to operate. He doesn't care if it's a reliability that failed or security. He wants to be able to know that his data are secure, and he needs to be able to know that the system that he operates have some sort of guarantees and find out who is responsible when they fail. Thank you.
Thank you, Angelo. So I think the score right now is 4-0 for the fence. Next speaker, Dr. Stephen Yao. I think you brought no slides, right? That was your email. You were just going to speak from here. He's the director of the Information Assurance Center at Arizona State University. He's a full professor. In his past, he's done many more things than I ever have or will, hopefully. He's been like editor-in-chief of IEEE Computer Magazine, and if I'm not mistaken, it was not in your bio, Steve, but I'm pretty sure you pretty much started the ComStat conference, right? And that's how many years? 40 plus? How many years has that conference been going now? What's the age of the conference, ComStat?
36.
Oh, it's 36. Okay, well, okay, I thought it was 40. But that's pretty good. I mean, that is probably one of the oldest living conferences in computer science. I don't think we have any more out there right now that have 36 on their age. So congratulations to you for that. So we'll let you come up and see if you'll stay on the fence or if you'll pick a side. Okay.
Well, thank you, Jeff, for the introduction. In fact, ICSI about the same time start. Okay. Well, I thought I'm the last one, but close to the last one. And being at the end, there's an advantage, right? Heard what the previous panelists said. Especially, I have not prepared any slides. The main reason is it should be dynamic.
Yes, absolutely.
I don't want to prepare some slides and find out what the previous panelists discussed. Okay. Well, first of all, I think the topic is very meaningful for this conference because this conference, what's the title? It's a security and reliability. Well, we all pretty much agree now that these two really not talk about meaningfully talk about which one trumps the other. It's really depend upon the reliability, the requirement, what the user wants. When we use internet and during the peak period, it runs smoothly, so it's reliable, you say. On the other hand, we all know it's not secure. Okay, you don't want to pass through confidential information without some protection. On the other hand, when we talk about the some operation, we want to be secure. If the things are not work, most critical point for me is make sure the confidential data in the system not get leaked out. I rather the whole thing destroyed, right? So you don't talk about reliability. But when we talk about the requirement, reliability and security are only two aspects. There are many others. Safety, we already talked about. Privacy, and more important, talk about the performance, the speed, response time. What happens if the things are slowed down, okay? And will not satisfy your requirement, and certainly that's very serious. And then you get more broader, the human factor get entered. Talk about the trustworthiness, privacy, okay? Now, trustworthiness is very broad, not the trustworthiness of the party you deal with, you interact with, but also the system, right? And doesn't matter what system. We have a lot of software outsourcing, a lot of equipment we bought. And do you trust? What is specification? Or how reliable are they? And what kind of security feature they have? Yeah, they may have some security feature. Are they effective? And do they work all the time? Okay. So really what we have to do is think about the entire view. On the other hand, reliability and the security, they have close interaction. If you get a poor software design, obviously, it's unreliable. At the same time, it's a lot of vulnerability for safety, for security. In fact, I'm teaching a course, a software security course, and it's a graduate level course. The student already taken software engineering courses and so forth. Well, even we teach software engineering courses, we don't have an effective way to teach a student to develop reliable software, right? A lot of them are gonna just, talk about a model and so forth, but when you put it in practice, it's very difficult. But when you talk about the security, then a lot of the things will show up immediately. You haven't considered this, you haven't considered that. Buffer overflow, all those things come up. And in fact, one of the interesting points for the student is we have a course project. At the end, I told the student, you try to test the others. And I give you a lot of incentive, you find vulnerability, and you also lose a lot of points if other people find vulnerability for your project. And in fact, and the main advantage I find is the student really get interested and they learn a lot of things themselves. I don't have to teach them. Hands-on experience. Okay? So this is just a show that what we should understand is, although it's a full requirement, then who decides the requirement? The user. Do you only look at a very specific aspect of your application, or you look at a much broader, long-term, and a major impact, a broader impact, and so forth? And a lot of users probably don't think about it that way. Only when they provide service, provide a product, more important is to get the investment return, right? Get the money back. And then what's the long-term, what we talk about later on. On the other hand, with the drastic change of environment, computing environment, especially the mobile devices and come out, well, the whole thing's a change. We talk about situation. What's a situation? Situation just by definition is, well, this is the room we are in a meeting, right? This is a situation, people listen and why. So, but if there's a fight next door, then everybody change and run out. The situation change. Or people get a disagreement, arguing, and starting get heated. That's a different situation. In application, IT application now, okay, ranging from cloud computing, global information system, involve anything, internet and so forth, or your local area network. A lot of situation change. When we talk about situation, it's not normally talk about whether the system is reliable or the capacity, the traffic, and so forth. Also involve not only the physical environment, the system environment, and also the human, the user. User had a greater impact to the system performance. You can imagine if a person gets very frustrated and will punch and pump, and you know what happened to your system, right? And also different people, different culture will react differently. So what I would say is when we look at these different aspect of quality of service, we have to look at the situation awareness, that the system is automatically built in the situation awareness capability, so when the things that come, and you want to, the system can adjust its configuration, its performance, and so that it can satisfy the user's requirement, not completely, but as best as we can. So that's my
Okay, great, thank you. And so we have Paul Black, Dr. Paul Black from NIST here, and he's going to bring us to the Q&A session. So let me get his slides up here. Let's see here.
While Jeff is talking about that, I think I will add one thing to my slides. We do not give the users what they want. We give the users what they need. I worked with enough users, and in companies many times, they don't think about their requirements very much. They think about what they need to get their job done. They think about getting their job done. It is our job as professionals to give them the things that they don't think about, the guarantees that they need for their job that they're not experts at. That's our job.
So now can I introduce you, please? You already took over the stage. So anyway, so I've known Paul Black for, what, about 20 years now? Yeah, he's been at NIST here for a long time. And, you know, he and I go back and forth. I'm a kind of a software testing guy, kind of like Jeff Payne and some of the others on the panel. And he's a formal methods guy, which I still love that term, formal Methodist, because I still think formal methods is a religion. But that's who Paul is. And so he'll get to his 10 minutes, and then hopefully we'll still have time for some questions and from you guys, and we'll get out of here probably right at noon. Okay?
All right,
Thanks,
thank you very much. One of these. Okay, which one moves it?
What are you doing here now? You just have to.
There we go. Okay.
Oh, you got it? Okay.
Got it.
Okay.
Got it. Okay, I am not standing on the fence. I am taking a stand here. Security trumps reliability. A highly reliable system must be secure. Otherwise, a bad actor can break in. If I want a system to be reliable, if somebody can break in and shut down my reactor, can empty the accounts from my bank, can reprogram my autopilot, I do not have a reliable system. So security trumps reliability, definitely. Also, reliability trumps security. Now think about this. If I've got a system that does not act reliably, if I have memory that breaks down, if I have bugs in my CPU, if I have bugs in my operating system, how can I build a secure system? What good does it do for me to build a Bell LaPadula model of security, prove that my system takes care of things, does things, if there is no reliability in the hardware that it executes on? And therefore, reliability must come first. You must have a reliable platform to build your system on, otherwise you can't have security. Otherwise, like the panelists said, the adversaries, their job, their hobby, what they dream about at night is to do the things that you never thought of doing, of overheating your chips, of coming in too fast, of using too much data, ruining your reliability and getting around that wonderful security model that you've built. Dependency loops are bad, okay? I said that each one trumps the other one. So let me give you a refined view. Rather than reliability as one big blob, let's split it into some pieces. I will say that functional fidelity, the reliability of an isolated execution model, must be the core foundation. From that point of view, Microsoft's trusted computing platform of giving you something where you know if I say add register 1 to register 2, it's going to do that. Unless, of course, it's physically destroyed or something like that. It's going to do that. That is a reliable platform. I can rely on it functioning in that way. On top of that, I need to build security. I need to build integrity so that nothing from the outside can interfere with the reliability of my model. I will not allow anyone that is not authorized to come in, put patches in my operating system, reload the BIOS in my computer system. So the security, the integrity, is the next layer. I don't have confidentiality. It would be embarrassing if they read what my passwords were, but that's a different concern. So integrity is the next one. And on top of that is reliability, and I've put just one aspect: the low failure rate, the correctness of computation, if you've got a distributed system and you have nodes that fail, then you have recovery. Those things can then be built on top of that. So I maintain that indeed I will take a stand, and reliability trumps security, which trumps reliability. Thank you.
And what kind of a stand is that exactly?
That stand is that we need a little more finesse. We need to understand, we need to break it apart into components, and we need to build an entire model that gives us what we want. The system components that are necessary to deliver the types of services that we promise as computer scientists and as computer engineers. So that's what I claim. Thank you.
Okay, thanks. Okay, so now it's what they call open mic. And there's a mic right there. Nihal, you want to come up and address any of the panelists? You've heard all their positions. And
thank you, Jeff.
Okay.
I'm Nihal Sinadure from the UK. There is a saying which says, "Fools rush in where angels fear to tread." So let this fool rush in where the angels at the panel did not tread. What I'd like to do is to sweep away the fence. I believe, by the way, the background from which I speak is telecommunications. A responsibility I had when I worked at British Telecommunications was to develop intelligent networks when we moved from hard digital switching systems to soft intelligent networks. At that time, what we did was we incorporated into the software, into the code that we wrote, a requirement that the code must be robust and couldn't be hacked. In other words, the intelligent network enabled one to transfer signals and route calls in a secure way that could not be hacked. Now, the word "could not" is not 100%. It's how robust can you make it. Okay? So in this case, the specification that we had was that the system should be secure as part of the reliability of the system. In other words, this was the requirement definition for the system. So security was embedded within reliability. I'll draw the extension also because more recently at Claro, I had responsibility for reliability, which incorporated quality. Quality was answerable to reliability. In the same way, security was answerable to reliability. So I don't want to make this rather grandiose claim that reliability trumps anything, but reliability incorporates security and incorporates quality. So those are the key things that I wanted to press here. I also wanted to add a comment on Angelo's comment about responsibility for software. One of the people who joined my team came out of an aerospace company, and the very frightening thing he said to us at one of our gatherings was the aerospace company started launching its first planes while it was still fixing its software. And God knows what vulnerability there was with that. So we tried to make sure that our software was as robust as possible, incorporating all of these things in there. Just also on the point of reliability, telecommunication systems usually require about a 20-year lifetime of a system. This doesn't mean that technology changes slowly. It just means that you have about 5 different generations of systems. As you change one out, you're putting new ones in. So the logistics of changing a system out requires 20 years. So the lifetime that you would require security for that particular system would be 20 years. So that's my comment. I'm happy to be shot down, so I withdraw as a fool, having challenged the system. Thank you.
Well, thank you, Dee. You want to start, Jeff? You want to just go down the line and comment?
Was there a question there? I know, I'm just kidding. So your definition, so I mentioned that if you define reliability as basically quality, which is essentially what you did by saying that quality was part of reliability, then of course it trumps security, because we all, I believe, I'd be curious to see if the panelists agree that if you define reliability that broad, then all the LDs fall under quality / reliability, and of course security is one of those, and yes, then reliability would trump security. However, most people or other people don't define it like that, so it depends again on your definition.
Oh, I still think we're talking about the wrong question. Angelos made a good point that I realized I should have probably brought that up too, but you know, this idea of Internet of Things, telecommunication systems are now part of the Internet of Things, right? You know, voice over IP. So you still have the PSTN, but it's connected to the VoIP, so the call goes through different types of systems. And coming back to our keynote speaker, it reminded me of 1987, or approximately, you can correct me on the date, but the Naval Research Lab, it's been 30 years ago now, almost, held a workshop on composition, basically looking at how do you deal with emergent behaviors. What are we doing today? You know, our systems don't really have boundaries. We're dealing with apps and services, and you know, our traditional thinking and reliability doesn't apply. I mean, how do you define an operational profile for something that sits on the internet? How do you know how the users are going to use it, and even who the user base is? Smartphones, Angelos works with those, and it's a real problem. We have one of our speakers spoke about the tech refresh cycle. I mean, it's so short, we can't go through the type of reliability assurance, or even, you know, thinking about security, because the product or whatever it is, an app, service, or system is obsolete within sometimes 8 months. There's a new cell phone coming out every day. Actually, in some countries like China, there's actually the introduction of probably 3 or 4 new phones per day. So, I mean, what do you do about quality? And then the workflow processes are changing. So once again, how do you define an operational profile? Because the technology we have today, where we're constantly connected, is actually changing dynamically how our workflow processes, and even just things outside the office space, how we enjoy ourselves, is changing. So, you know, I don't think we know how to handle reliability or security for anything today. I mean, we're in a bad situation.
Since the comment was from telecommunication industry, I want to point out that although the end-to-end argument served us very well so far, I don't know if it's going to be able to serve us going through the future, because the end devices becomes too smart, and frankly, like the Internet of Things makes every single small device that you have in an organization be equally problematic in terms of security than big machines. So your servers might be secure. Are you sure about your TV? Are you sure about, I mean, my TV now is smart. It updates itself from the internet. What happens if malware goes there? Am I responsible for every single thing that's connected to the internet within my organization? The answer is yes. The question is, can I rely on myself patching all these systems? The answer is no. So we are in a very nice situation where everything is connected, and the intermediate network has let's say, intelligence whatsoever, but that might not be what we want going forward. It's too much to have everybody glued together and not have at all control of, you know, who does what.
So I don't know, I have a couple of comments that maybe will inform the gentleman's comment and position. A couple of weeks ago, 3 or 4 weeks ago, I was at a much smaller conference on safe and secure software systems not too far from here in Annapolis. And there I was presenting on a topic that I've been presenting, in fact, at a previous conference sponsored by Paul. and that has to do with licensure of software professionals in the United States. I've been very involved in the process that over the last 4 years that has now led to 30 states will require licensing of software engineers who are public-facing, that is not exempted by an industry or government exemption, public-facing, working on software systems that are critical. And so what I mean by that then is it answers partially Angelos's concern about, who do we blame if the software fails, just as we ask who do we blame if the bridge fails. Well, the licensed professional engineer who is in charge accepts responsibility. But that's only one tiny piece of the problem. At this conference, and I'll finish soon, I don't want to do too much of a monologue. At this conference, Paul Giuano, a friend of ours who works on nuclear power systems, software for nuclear power systems, he had a nice little diagram that I have to steal from him. It showed a bunch of sled dogs, he's from Canada, pulling in different directions. One had to do with licensing professionals. One had to do with testing and certification of systems. One had to do with educating professionals in the various areas of reliability, safety, security, privacy, and so on. One had to do with, enforcement. And they're all pulling in different directions. And the next slides show them all pulling in the same direction. And the point being that getting more to the solution of the problem, reliability versus security, it's a composite question, and it requires a composite answer. And so I can't worry about my smart television updating itself. I can't test each device like that. I have to trust and hope that the standards that apply to that television, that the engineers that worked on that television, that the telecommunications network by which it's communicating have all been subjected to some standards and some process. That's all I wanted to say. I'm sorry.
Well, I think telecommunication is a good example that you need both reliability and the security. You cannot, miss one of them. With the growth of use of mobile device, of course, security is getting more and more important. Okay, people want a convenience. At the same time, we expose to other vulnerability and for the hacker to attack. And so I think it's a challenge. This is one good example, but of course, in every application, we needed to look at the requirement and try to cover as much as we can.
Thank you. I think I will agree with Phil that that we need to trust other people. Let me call for a return to virtue and honor among computing professionals. I will disagree, I don't think that there's any number of standards or tools or technology that could deliver reliable systems if we ourselves in large don't care, are not consummate professionals. It is people driven. And if the people don't deliver, then we can't have those systems. I was, with regard to new systems all the time, I remember driving before the oil crisis in the United States in the 70s. Cars were very poorly made. During the oil crisis, people finally woke up to the quality of cars coming out of Japan. Detroit almost went out of business. It took them years to realize that they could make cars that were highly reliable. I buy a car now, I expect it to run 5,000, 10,000 miles with no service except maybe some oil and gas. This is expected. It didn't cost that much more. It was a matter of caring and expectation. And I would really like to see our software and our hardware, our systems, get to that same level. Thanks.
Okay, so I would just like to make a comment on the importance of context. Having thought about requirements for a long time, I would also agree with Jeff that the answer to that question is, it depends. One of the things I've done over the years is I really haven't spent any time thinking about reliability other than to know the classic definition. But I have thought about security. And security very much depends on the context, what security means. When back in 1984, I wrote a paper on the Secure Military Message System project with Carl Landwehr and John McLean. And the point of that paper was that the Bell-LaPadula model was not a good model for military message systems, that we need to be able to write down. And there were huge fights about that. And then I noticed today that Paul defined security as integrity. Well, integrity was not anything that we proved when we reasoned about data separation. Integrity just doesn't, it wasn't one of the security properties of interest. And so I'll reiterate again, I don't think you can ask this, I don't think you can address this question out of context, that you really, security depends on the context. It depends on the requirements of the application.
Any other questions? Yes, sir.
This might be very simple to answer. It would seem your arguments are all revolving around, is there always an adversary? So security matters when we believe there's always an adversary that's going to attack the system. And if we believe that's true, and now just everything is about reliability. An adversary attacking the system, you just have to build it in, because to have the system be reliable, if you always assume there's an adversary, you need that security as part of your base system. So maybe just a poll among the panel of, are the days of our naivete gone, in that we now have to always assume for every line of code we write, there's an adversary who may want to attack it?
I think so. Yeah, I would. Panel, raise your hands. I think we have to assume an adversary. I think we have to.
The Internet of Things changed that. I think the Internet of Things changed that. The Internet of Things changed that. Because now you have, if you have a safe box inside your house and the door is locked, you don't care about it, right? But if you have your mailbox that everybody has access to in a public street, and you're living in a bad neighborhood, you sure don't want things to be there. You care more about security there. So it's the Internet of Things that changes things. We are glued together. I can access systems, miles and miles away from here, and they can access systems here too. So that mentality, unfortunately, changed. And until we create again the mentality of being able to secure things and put them behind locked doors like we had so far, if we can manage to do that, then it's a global economy. We like our TVs to be updated, right? That means that other people can reach the TV and update it too. So that's the problem.
No, I wouldn't agree. I don't agree that. I agree we have to look for adversaries, and you should look carefully at all software, but that doesn't necessarily mean there are adversaries for every piece of software. There is still a lot of software that's not connected to the internet, contrary to popular belief. All right, and it sits behind a locked door or whatever, and it's on someone's machine. I would argue that software doesn't need to be secure any more than the physical security that's provided to it. Yes, so I would not say that it necessarily always trumps. However, be very careful about being blasé about what is and doesn't need to be secure. A great example is Microsoft had, you might have read about this story, so Microsoft has a game called Hearts that it distributes with its software, with its operating system. And, because it was the game of Hearts, no one thought that there was any reason why you'd need to do any kind of security analysis on it, and therefore, that it was kind of precluded from their security process. Unfortunately, Microsoft Hearts used a shared library that had a vulnerability in it that also was used in other places in the operating system, and someone figured out how to go through the game of Hearts and break into the operating system. That was an example of where you have to be very careful to make sure you don't just blanketly assume that something doesn't need to be secure. You have to do the analysis, but that doesn't necessarily mean that in the end it does need to truly be secure.
Steve wants the...
Yeah, I like to add one aspect. Certainly, we like to have a reliable system. We like to have a high-quality system. We like to have secure system. But there's a cost involved. Okay? So we have to look at it from application point of view, what kind of a risk analysis, risk management, all this kind of thing enter the play. So we can build a castle, but whether it's worth it. So I think that there are a lot of good techniques we can employ, we can integrate or use into the system. But the bottom line in many of the applications depend upon the cost. Of course, when we talk about special system like national security and so forth, security is very important, the highest priority. Okay? So we have to, at the bottom, yes, we still have to consider the requirement and the application.
I hate to short. I have to add one thing. I worry, in a way, I disagree with Jeff. Yeah, it's true that there are systems that are built that are not intended for public exposure, but the problem is these systems that were not intended eventually find their way. The SCADA systems that were never intended to be initially connected to the outside world somehow. And the transitive closure of all the software that people write, it manages to find a way out. Now, I've thought about using this notion that Jeff has talked about, the underwriter laboratories for software, certifying this software as being secure or ultra secure and others as not, might be the way to go. But the problem with that is we still have to publish on ladders. Do not stand on the top of this ladder, and we still have to publish on toaster ovens. Do not put fork in toaster oven. I mean, we can't rely on a warning system because people find creative ways of ignoring them. So that's my worry, and I may be worrying unnecessarily. I don't know, did you want to say? Thank you.
Oh, there you go, Liz. Okay.
A quick question about issue of cost. If you have only X amount of dollar, would you want to spend the money only on fixing an elevator, or spend that dollar to put a little camera on the elevator? So depending on security requirement or reliability requirement, the question of cost come up. And I wanted to have a poll from whoever in the panel that if you only have that much money, how would you want to spend it?
Well, I got the microphone, so I guess I have to answer first. Let's see. If it's the elevator might plummet to the ground floor and I die by elevator crashing, or there is a mugging in the elevator and I die by mugging, I'm not sure which way I would prefer to die. It's hard to say. I'd have to look at what the actual risks are and decide. For me, with my skills, I would rather, if the elevator crashes, I would die anyway. If somebody attacks me, I would scream and cry like a baby, so I think I might not die in that case, so I would put my money on the elevator.
Yeah. Okay. Everybody?
My answer is, what's your business model? What makes money for you? If bad software makes money for you and you can get a new version, I bet that people will just create a new version. If your product is about security and you're going to get a bad name and lose money, then people will put it on security. But really, it's the business model that matters at this point. I don't believe that people are motivated by, nobility or, they have to be motivated by something more than just a standard.
I sit on the fence still because I still say if you have security policies and mechanisms, you still have to use reliability techniques to do the assurance, and you can't separate the two. And you have a finite amount of money in your engineering budget to do what you need to do, so you may have to cut back on the security capabilities of the elevator system. I'd rather live and have the safety functions of the elevator always operate just like an automatic train protection system. I want to make sure that the safety critical functions always work as specified and put all my, as much as the assurance budget into that, and that would be my choice.
Yeah, I would agree. So back to my original point about safety being, loss of life being probably more critical than some certain security vulnerabilities. I would bet and want to make sure the elevator actually didn't plummet to the ground, versus I'll take my chance with a mugger in that situation. But that brings up the trade-off comment that Brett made, which was that the most secure piece of software computer is one that doesn't work. It's buried in concrete and you can't turn it on, and the disk has been eradicated, right? But that's not going to make anybody any money. So therein lies the challenge. You have to trade these two off.
One more question. We'll take one last.
Can I? I saw the slides from Phil, and it occurred to me that it looks like the surveillance capabilities are increasing through time. So the privacy, Phil said that it's not clear which directions we are moving, but it sounds like the privacy is decreasing through the time. So, for example, if the British in the 18th century had the similar methods that the current governments have, then probably the founding fathers would not have a chance. Paul Revere would be probably would be found by some graph analysis techniques or something. So I want to ask you what you think about it.
No, I agree with you. I didn't mean to imply that our privacy is the same now as it always was. I think our privacy, because of the technological capabilities, as you suggest, is so great that we're giving up more and more and more of it. What I'm conflicted about, and what is I think a constant, is that we accept a level of trade-off between security and privacy. Now, maybe we didn't know in the 20s or the 40s or the 30s or even in the previous century before that we were trading off privacy for security. Now it's very obvious because of the internet. So yeah, clearly you're right. The country would have never been founded if the King George could have wiretapped the revolutionaries in Philadelphia. Absolutely true. And this changes the geopolitical landscape tremendously, I think. But I think that's probably another issue for a different panel. I'm not an expert on it, but good point.
Thank you.
Okay, I'm just going to throw in one last comment, then I'll let you guys go. It came, I remember the days when Jeff and I, we used to work together, and I was pretty stunned when I learned back in those days that one of the huge contractors that was building safety critical software, and I'm not going to say that they actually wanted more bugs in the code, but they made more money by having bugs in the code because they didn't make any money writing the code. They made money maintaining the code and getting the bugs out. So the more bugs they could put in, and I don't know if the industry's changed that much today, but it's a completely true story. Jeff, will you attest to that? You remember who it was? Oh yeah. And so I was always amazed at the fact that actually the more you could seed it with problems, and then you could get the money to get the problems out, then actually that's how you made your money. So it was always interesting. So that was based on a comment prior. Well, I'd like to thank you guys all for attending this panel. I have a slight little gift for each of the panelists that's sitting right behind them. I know that one of the people sitting there actually likes what he's about to get. I don't know about the other 5. So anyway, so